Hi. So today we will discuss significant figure in algebraic operations. When you do certain experiment, or when you find something, like when you find density, then you have to calculate mass and you have to calculate volume, and mass per unit volume gives you density. There are so many other investigations in which you add two values. So when you add two values, two measured values, then how significant figures are considered. Let us learn today that thing. So significant figure in algebraic operation, the first case, addition and subtraction. You take measurement of lengths of two different things, and suppose you measured one length 3 point or 2.3 centimeter, and other length you measured 2.402 centimeter, and finally you add it. After adding you get 4.702 centimeter. So you see that your first measurement was least precise, as its significant figure is only 2 and your result is having significant figure 4. It is more precise, more accurate. You have obtained something using some measurement, the measurement which is least precise, least accurate, as it has significant figure only 2, and finally you obtain a result which is more accurate, more precise. This cannot be done. So here the significant figure is changed, and we retain the number of decimal digits in final result, number of decimal digits in least precise number in the final result. Here you have, आपका जो least precise number है वो ये है 2.3 है. ये आपका ज़्यादा प्रिसाइज और ज़्यादा एक्यूरेट नंबर है, क्योंकि ये डेसिमल के थाउजेंड्स प्लेस तक गया हुआ है इसका मेजरमेंट. तो आपका रिजल्ट जो आया, इट कैन नॉट बी even more precise, more accurate than the thing from which you have derived it. So in addition and subtraction, we retain the decimal digits of least precise number in the final result. 2.3 has significant figure 2. So final result should also have significant figure. Okay, has decimal point 1, not significant figure. Here we will retain decimal point. In addition, in subtraction, number of decimal digit is 1. Number of decimal digit is equal to 1. So final result also should contain only one decimal digit. Therefore, result that is equal to 4.702 centimeter, it must contain only one decimal digit. So you will just remove this number, and the final result will be equal to 4.7 centimeter after rounding off. After rounding off. तो राउंडिंग ऑफ की क्या जरूरत है? यहाँ पे ही राउंडिंग ऑफ की जरूरत है कि हम कुछ मेजरमेंट करते हैं, फाइनली हम उस मेजरमेंट्स को हम फिर किसी एक्सपेरिमेंट के लिए वी यूज दैट मेजरमेंट्स एंड वी डिराइव एट some result. So that result must not be even more precise, more accurate than what you have measured, than what you have calculated. So for that sake, we need to round off the number in our final result. So what is rounding off? Let us consider. Rounding off. Suppose you have a number 4.0253 and you have to round off these two numbers, then you will see that. Let us learn rounding off with help of an example. Suppose you have a measurement 4.4532 or 45, okay, let me change the number, 4372, okay, this much centimeter. So you have to round off these two numbers. You have to round off 7 and 7 is greater than 5. If a number to be round off is greater than 5, then the preceding number will be increased by 1. A number which is to be rounded off is greater than 5, then the preceding number will be increased by 1. So the number is changed to 4.4 centimeter. This is result. Rule 2, if the number to be rounded off is less than 5, then the preceding number will remain unchanged. Then the preceding number will remain unchanged. Okay. So in this very example only, you have 4.3 and okay, the round number to be rounded off is 2 or 3 or 4, anything, 4542 centimeter, and we have to round off up to this. Since it is smaller than 5, then result will be 4.3 centimeter. The preceding number will not change. Now, third rule, if the number to be rounded off is 5 or 5 followed by 0. Then, two rules are there. If preceding number is an even number, the preceding number is an even number, then it will remain unchanged. Rule 2. If the preceding number is an odd number, then after rounding off, it will be increased by 1. So let me show you with the help of an example. In the two cases, we have two cases. Okay, this one case, example 4.45 centimeter. Then result will be only, I have to round off this number 5, then result will remain 4.4 centimeter. The preceding number will not change. But when we have example 2, when we have preceding number and odd number 3 or 7 or anything, and it is followed by 5 or 5 followed by 0, this much centimeter, and we have to round off the number, then result will be equal to 4 point, the preceding number will be increased by 1, this much centimeter. So this is your third rule. Fourth rule, if the number to be round off is 5, which is followed by some non-zero digits, non-zero digits means it is greater than 5. In that case, we should increase the preceding number. Let me take the previous case, example 4.352 centimeter. So you have to just round off this number, then result will be equal to 4.4 centimeter only, because in this case also, example 1, example 2, let me take another example, 4.453 centimeter. Here it is an even number, but still this 5 is not followed by 0, it is followed by some non-zero digits, so it is greater than 5. This portion is greater than, okay, so we need to, in each and every case, we need to increase the preceding number by 1. So the result is 4.5. So these are the results of rounding off. And why we do round off the numbers? So while doing some investigation, if we add any two results, then the final result should not be even more precise, more accurate than the result we have measured. And this is why we should do rounding off the numbers. Here you can see that this number is more precise. It has 4 significant figures, and this result is least precise, and it has 2 significant figures. Significant figure in multiplication and division. Many a time, while doing investigation, while doing some experiment, we are in need to multiply or divide certain set of numbers. Like for volume, we multiply area with that of its length. We multiply two things. So in that case, we need to retain the significant figures of least precise number. In multiplication, let me write rule first of all, then I will show you with the help of an example. Significant figure in multiplication and division. Okay. We retain in result of multiplication or division. The number of significant figures. Of least precise number. As the result cannot be even more accurate, more precise than the least precise measurement. So let me explain with the help of an example. Suppose the area of any wire or any tube is equal to 2.4 or anything, 2.4 meter square, and length of the wire is equal to 4.279 meter. So for volume, when we multiply the two, volume is equal to area into length. So let me multiply 4.279, 2.4. So we get 3. Okay. 19, 18, 1, 14, 15, 5. Is 18, 1. So we have 4, 2 to the 4, 5, 2 to the 8. Okay. So when we multiply, this is 6, 3, 10, 3, 4, 28, 29, 32, 10, okay, 1. 8, 1, 9, 5, 1, 6, 2, and this is 10. And when we put the decimal point, 3 plus 1, 4, 1, 2, 3, and this is from here. This is final result. This much meter cube. So you see that in the two measurements you have significant figure. In first case you have significant figure 2. In second case you have significant figure 4. But in result you have significant figure. Count the number of digits. 1, 2, 3, 4, 5, 6. How it can be that you measured certain values which is least accurate, least precise, and when you do some multiplication and division to obtain certain result, it becomes even more precise. So here we need to retain the number of significant figure in case of multiplication and division. In case of addition and subtraction, what we did, we retain the number of decimal digits in least significant number. But in case of multiplication and division, we will retain number of significant figure of the least precise measurement. Here it is 2 only. So keeping 2, we will remove every other number. Here you can see that 2 is smaller than 5. So we will leave the number, after the rounding of this, we will leave the number as it is, which is precedent one. Therefore result should be equal to 10 meter cube only, because its significant figure is 2 2। तो हमने क्या देखा कि जब हम मल्टीप्लाई करते हैं और फाइनल एक रिजल्ट पे हम आते हैं, तो हम क्या करते हैं कि सिग्निफिकेंट फिगर जो है ना, जो लिस्ट प्रिसाइज नंबर है जिसका सिग्निफिकेंट फिगर कम है, हम फाइनल रिजल्ट में वही सिग्निफिकेंट फिगर रखेंगे। तो हमने यहाँ मल्टीप्लाई किया, हमें सिग्निफिकेंट फिगर आ गया 6, जबकि जब हमने मेजरमेंट किया था तो रिजल्ट हमारा इतना एक्यूरेट नहीं था, सिग्निफिकेंट फिगर या तो 2 या तो 4 था। तो हम इसको राउंड ऑफ करेंगे और राउंड ऑफ ऐसे करेंगे कि हमारा सिग्निफिकेंट फिगर 2 ही रह जाए। तो अगर यहाँ 5 से बड़ी कोई संख्या होती तो हम प्रीसीडिंग नंबर को, इन केस अगर ऐसा होता कुछ, यहाँ 6 हो जाता, 6, 9, 6, ये संख्या, दिस नंबर इज ग्रेटर देन 5, सो आफ्टर राउंडिंग ऑफ वी विल इंक्रीज द प्रीसीडिंग नंबर बाय 1। तब ये हो जाता, इन केस ऑफ दिस रिजल्ट विल बी 11 मीटर क्यूब। अगर ये आपकी संख्या एग्जाम्पल 3 हम ले लें, अगर आपकी ये संख्या है 10.500 मीटर क्यूब, then we will see that each preceding number is even or odd. It is an even number, so we will leave the preceding number after rounding off unchanged. अगर ये आपका यहाँ पे preceding number odd number होता तो हम इसको रिजल्ट, फाइनल रिजल्ट में 1 से इंक्रीज कर देते हैं। it will become 12 meter cube. So these are the rules of rounding off. Why we do round off? Because in principle the final calculation, final result after doing certain mathematical operations on two calculated value, the final result should not be even more precise, more accurate than what you have calculated. And this is why we do round off the result. Okay.